Review polynomial functions and equations. Find the function graph's end behavior. You see this big equation here, and it says as x approaches positive infinity, what happens to y? Y is basically the graph, okay? So that means if I graph this, if I made a table with a bunch of stuff, plugged it in for x, I'd get a bunch of random points. And as x goes to positive infinities this way, okay, what happens to the graphs? It go up or go down? Negative infinity, what's it do, up or down? Now, fortunately, there's a way to tell without having to graph it. It's by deciding your leading coefficient and your degree. Now, the x being positive infinity, that's where the leading coefficient comes in. It's -2. It's negative, so that means as we go out into positive infinity, the graph just gets lower, so it goes to negative infinity. Had that been positive 2, it would go to positive infinity. Now the degree is the highest power, it's 4, and that depends on whether that's even or odd. 4 is an even, so when it's an even degree, the end behaviors have to match. So it'd be negative and negative. That means on a paper the graph would maybe do something like this. I don't know, but it goes kind of all over. They both go down in the end, okay? Now, let's use the algorithm to figure out the next two. So leading coefficient, LC, and degree. Leading coefficient's 3. This time it's positive 3. So that means as x goes to positive infinity, y also goes to positive infinity. Now the degree this time is 3, so that's an odd degree, so that means it's a non-match. The end behaviors don't match. So if that's positive infinity that way, it's going to have to be negative infinity the other way. So again, an example of that would be if I graph this, we'd go up this way, then it'd do a bunch of stuff all over the place, and then going that way and ends up going infinitely downward. Okay, leading coefficient is positive 4. So again, it's positive, so as x goes to positive infinity, y is positive infinity. And then the degree is 4, which is even. So that means that has to be a match. So since that's positive infinity, it has to be a match. They both go positive infinity. Okay, next one. Write a polynomial function given the roots. Only real rational values can appear in the final equation. What real rational means is in the end. Now you're going to have some at the beginning when you first write it sometimes. Only real, that means no I, can't have any i's in the final answer, and you can't have any square roots in the final answer. Okay, they have to be integers, they have to be real. I shouldn't say integers, they just can't have no i's, no square roots. Well, the first one's an easy one, okay? -3, -4, and 10. So y equals, and you start writing parentheses, x, you always start off with minus, but if it's a negative it goes plus. X minus plus 4, x minus, and then 10, and that's the end. That's my final answer. I don't see any i's, I don't see any square roots, we're good. Okay, number 5, now you see some i's and square roots. Now, i's and irrational square roots come in pairs. So if I see 5i, that means -5i is also a root. Square root of 6, that means negative square root of 6 is also a root. So I start off the same as I did with 4. X minus, but then since I have -5i, I go plus 5i. X minus, and then that one's just 5i, so that slips right in there. X minus, since that's negative square root of 6, we write plus square root of 6. Then x minus square root of 6. You can't leave the answer like that, okay? This needs to be multiplied out, and so does this, so that the irrational square roots and the i's can go away. Now there's quick ways to do that. Now I want you to just focus in on how I'm multiplying this. X times x times 5i, negative 5i times x, negative 5i times 5i. So that's x second, 5ix and negative 5ix cancel. And then I get negative 25i to the second, but since I to the second is negative 1, it goes positive 25. So that's x second plus 25. Now the quick way to get that is when you're multiplying conjugates with i's, you just go x times x, and then it always ends up being a plus with the i's, and then 5 times 5 is 25. Because 5 times negative 5 is negative 25, but since they both have i's, it's I to the second, which makes it positive 25. Now let's take a look at how I'm doing the square roots. It needs to be multiplied into one parentheses. X times x second. X times the square root of 6 is square root of 6x. Negative square root of 6 times x is negative square root of 6x, which gets a cancellation. Negative square root of 6 times square root of 6 is negative square root of 36, but the square root of 36 is 6 whole, so it'd be negative 6. So x squared minus 6. Now to get that a little quicker, we square the x's, x squared. Now when I'm multiplying two opposite square roots, it's a minus, and then what happens is the square roots just come off the 6's and gives me 6. Now let's apply that without having to FOIL it because it takes too long. Y equals, now this one doesn't have a partner, okay? There's no I, there's no square root. This has an I, so it needs a partner. This is an irrational square root, since the square root of 10 is some decimal, okay? That never ends, it's irrational. It goes right there. So y equals x minus, but it goes plus 4. And then I go x minus goes plus 2i, x minus and then 2i, x minus and then plus square root of 10, x minus square root of 10. Okay, now the x plus 4 is fine, but I don't like those i's, so I need to multiply those and those. Remember how to multiply conjugates of I. Conjugate means they're the same thing, just a plus and a minus. You got x second. Multiplying i's will switch the negative to a positive, and then 2 times 2 is 4, and the I goes away. Okay, x second. Multiplying two irrational square roots, opposites of the same irrational square root, means you will have a minus, and the square roots come off and gives you just 10. That's it. I mean, if you want to take a scratch paper and FOIL it, that's fine. Okay, find all roots in the equation by factoring. Okay, if you're wondering what that means, factoring means you better draw some boxes. You got 3 roots to find because you got a third power, and you got 3 terms. So GCF and table. The table will work. I wouldn't tell you to use factoring if it wasn't going to work. Now GCF. 5, 8, and 4 only appear in the first row, so that makes it 1, but they all have x, so it'd be 1x. So I factor out 1x. If it's just 1, you don't do it, but with 1x, you do. They cancel right there. That's going to be 5, and that goes to x to the second, minus 8, that goes to x, minus 4. Now, you're ready to get your first root because you have that 1x out there. Just set the 1x equal to 0, and 0 is your first root. Pretty easy to see that. Now the other 2 roots, we're going to try to factor this trinomial here. 5 times negative 4 is negative 20, and we need to add to get negative 8. Positive times negative if it's a negative, so 1 and 20, nope. 2 and 10, there it is, negative 8. Now pay attention here. What's your a equal? Your a is 5 with x to the second. So if you have a 5, to factor it correctly, you want to make 4 parentheses instead of just 2. You want to start with a 5. Don't split that number. I don't care if that's a 4, a 10, whatever. Don't split that. Split that one. That would just go to x and x. Plus 2 minus 10. Now that's only in the first row, so that stays 5x plus 2. So I set that equal to 0. Now in the other one, that's in the 5th row, so we divide by 5, and that's going to be x, or 1x minus 2. You set that equal to 0. Then you're good. It's going to give you 2. And that's going to give you negative 2 fifths, or negative 0.4, same thing. Okay, number 8, x to the 4th plus x to the 2nd minus 20. If I don't tell you different directions, you're still factoring. So that's 4 roots this time because of the 4th power. Okay, we have 3 terms, so it's GCF and the table. Now 1, and that's a 1 there. 1, 1, and 20 would just be in the first row, and we wouldn't do an x because there's that 20 at the end that doesn't contain the x, so don't do it. Okay, 1 times negative 20 is negative 20. So again, since that's a negative product, it has to be a positive times a negative. And I want the factors have to add to get positive 1. Nope. Nope. 3 is a decimal. 5 by 4, you get 5. Okay, now that's negative 1. We have to get positive 1. So if I go plus 5 minus 4, we're there. Now your a this time is 1x to the 4th. Okay? Now, since you have a 1, you can drop the 1. So you just need 2 parentheses. But your x to the 4th has to be split. X second, x second. So minus 4 plus 5. Now, since these both still contain even powers, second powers, take them over here. We didn't have to do it on the top problem because these were first power x's. No exponent. But when they're second, you need to take them over here and see if you can factor them as difference of perfect squares. So DOPS, question mark, DOPS, question mark, plus minus, plus minus. That's x and x, that's 2 and 2, so that works. And I don't need i's because it was a minus, okay? So I can get my next 2 roots, so I can get my first 2 roots using these. That's now gone. I get negative 2. And the other one, x minus 2 equals 0. That would be positive 2. Okay, now I still got 2 more to go. Now I can't do, 5's not a perfect square, so we can't do that. So we have to just set that equal to 0. And that will be 2 roots because of the second power. So I'm minus 5. Take the second power off, apply a square root. Now when you have a negative under a square root, you got to make it positive and put I. Now 5 cannot be divided by anything up on that board, okay? So all I do is put I square root of 5 and then I square root of 5 with a negative in front. There's no sense dividing because the only thing 5 would divide by is 1, which is worthless. Okay, now remember these answers because you have to come back and look at those roots and do something on a later problem. Okay, number 9, same thing. I didn't give you new directions, so you're still factoring. Now we seem to have 4 terms though. 4 terms, I set up the grouping. Grouping, and then at the end there's going to be one of them you do a dot. So grouping, parentheses plus parentheses, that's a plus. Remember you get that plus in between. And then line parentheses plus line parentheses, and then line parentheses, put a little parentheses here. And then this parentheses here will still have a second power, so we'll have to check that for a DOPS. Okay, so we got 1x cubed minus 4x squared, and you got negative 9x plus 36. Now divide, but each parentheses is its own dividing. 1 and 4 would just be in the first row, but this last one has x to the second, so you got to pull down x second. 9 and 36 is in the ninth row. It wouldn't have x because 36 at the end is a constant, doesn't have x, but it would need a negative because of that first number's negative. So I'm going to put whatever I'm dividing by goes out here, whatever I'm dividing by goes out here, and hopefully these end up the same. That's a negative 9, by the way. So it's going to be 1, and then x third divided by x second is x, minus 4, and those go bye-bye. And this will be the same thing. That's 1x, and negative 4 means I write minus 4. So since these parentheses match up, I'm allowed to put 1x minus 4 out there, and then forget those. Now I put the 1x squared with the negative 9, so it's 1x second minus 9. Now see if that's adopts. Forget the 1. Adopts with a 1. If now it's a 4, you go 2x, 2x, but just a 1x squared, just x and x will do. 3 and 3. Don't need I because it has a minus. Okay, and those are your factors. You got F1, F2, F3. You set them equal to 0 individually. You don't need to do anything here because they all ended up, good. X plus 3 equals 0, x minus 3 equals 0. So that's 4. You don't need to divide by 1. This is going to be negative 3. Don't need to divide, and positive 3. Okay, 10's an easy one if you know what you're doing. Refer to the solutions for problem number 8. On the graph, y equals x fourth plus x squared minus 20. Find the following: the roots, the x-intercepts, the y-intercepts. Now this is the same as problem number 8, but instead of having equals 0, it's equal to y. Okay. Now the roots are the answers we came up with. Just copy them down. Negative 2. Positive 2, I square root 5, and I square root 5 negative. Now, which of those are your x-intercepts? The negative 2 and the 2 are, but anything with an I is not an x-intercept because those don't come on. They're called imaginary, means they don't appear on a graph. Okay. Now, the y-intercept's easy. It'd be all your x's taken out of the problem, and y equals negative 20. That's all there is to it. If you have an I, you don't put that in your x-intercept set. Okay, synthetic division, find the quotient. It means set up your synthetic division. To find your outside, you take this, x minus 1 equals 0. Add 1 to both sides, you get 1. So 1 is your divisor. Now line up your coefficients. You got 1, 3, 1, positive 3, negative 1, negative 3. And then you drop the 1, and then you take 1 times 1, but you don't put 1 here, you put it here. 3 plus 1's 4. 4 times 1's 4, you put 4 here so you can add it, and that's 3. 3 times 1 is 3, and I get 0. Now, how do you write your answer? Don't just stop there, okay? That 1 used to be an x to the third. Well, now it's an x to the second. Plus 4x, plus 3, and we have a remainder of 0. Now, if I have a remainder that's not 0, I have to do something with it, but let's worry about that when it happens, if it happens. Okay, x plus 4, set that equal to 0 by subtracting 4. And you got 1, negative 7, and 20. Drop your 1. 1 times negative 4 is negative 4. Then you add negative 11. Negative 11 times negative 4 is 44. Then you add. And that's going to be 37. I'm most definitely not going to get a remainder of 0 here. I mean, you can tell. So 37 times times negative 4, negative 148. Add those, it's negative 128. Now, how do you write your answer now? Well, you do the same way. You go 1, and then it goes from x cubed to x to the second minus 11x plus 37. And then here's how I write the remainder. I put minus 128, underline it, and just put the expression x plus 4. Not 4, the entire expression x plus 4, because that's what you're dividing by. The remainder goes over what you're dividing by. Okay, number 13. Use irrational roots theorem to find the equation's solutions. Now, it doesn't say factor, okay? It says rational roots theorem. So that's RRT. I'll jot that down. How many roots? There's 3. 3 solutions. Okay, irrational roots. You make the underline, take the constant at the end. If it's negative 6, but just worry about 6. Then you take the leading coefficient, 1. So what are your factors of 6? You got 1 and 6, 2 and 3, and that's all she wrote. 1 is just 1. So if I take all of these and divide them by 1, it's just those. 1, 6, 2, 3. Now what do I do with that? Well, I plug them in to see if I can get 0, because I've narrowed down the possibilities. It's trial and error, but I can limit the possibilities using the roots theorem. Okay, didn't take long. I got 1. If 1, I'd go to 2, then I'd go to 3, then I'd go to 6. If none of those worked, then I switch to negatives. Okay, now I use the synthetic division because I have my dividers are 1. And then you got 1, 4, 1, and negative 6. Carry your 1 down. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 6 times 1 is 6. Then you get 0. All right. Now, what becomes of that? Well, now it's 1. Instead of x cubed, it's x squared plus 5x plus 6 equals 0. Now, you got 3 terms, but sometimes on these, the t-chart doesn't work. There's an easy way to find out on your calculator if you use the discriminant. That's just the square root portion of the quadratic formula. Double parentheses when you're doing it on calculator. So 5 to the second minus 4, 1, and 6. Okay, it's rational, so I want to see t-chart, okay? GCFT. GCF would be 1, not with x. 1 times positive 6, positive 6. So it's either a negative times a negative. Could be switched to a positive times a positive. We'll see. 1 and 6. Nope, that's negative 7. Divide by 2, you get 3. That's negative 5. I could just go plus plus. Now a is 1, x to the second. So pretty easy because the 1 can be dropped and x second can just be broken up into x and x. Okay, then you're good to go. X plus 2 could equal 0, or x plus 3 could equal 0, which gives us negative 2 and negative 3. Okay, now these things. Use properties of exponents to simplify the expression. Properties of exponents means the 3 lines that you draw on all these. Write down your basis first. Here's the line to start with. Everything's above it. You got 5 and 6 as your numerical basis, and then x as your variable base. Just write it once. So 5's to the first, but since it's in a parentheses to the third, you take 1 times 3, and that's 3. 6. 1, but in a parentheses to the second, 1 times 2 is 2. Now you got 2 x's, but they're straight across. You don't have one on top and bottom. They're across, so that would be an adding. So 2 times 3 is 6, and 3 times 2 is 6, and 6 plus 6 ends up as 12. So you add when they're multiplied across, okay? Now, here you're going to do minus because one's on top, one's on bottom. But when they're on the same side of the line, you're adding because that's multiplication. When you're multiplying common bases with exponents, you add their exponents. Okay, all these are positives, so we don't need to do anything there. 5 to the third is 125. 5 times 5 times 5. 6 to the second is 36. X to the 12. Please remember to multiply 125 by 36. 4,500. Okay, number 15. Bases 9 by x by y. 1 times negative 3 is negative 3. 2 times negative 3 is negative 6. And then 18. Notice I don't do any adding because there's only one of each. Okay, these two guys here need to be moved to the bottom so I can rewrite their exponents as positives, 3 and 6. Now the y I keep because I want him to be positive. And then we need to simplify the 9 to the third. 9, you can hit that key there to the third, 729. Okay, number 16, bases, you got 30. X and Y. Now I have a 5 on bottom, but I don't write X and Y on bottom because they're already on top. Now 30 is to the first, okay? It's not in a parentheses, so I just put it to the first down here. Same with the 5. Now, you have multiple X's, but this time they're not being multiplied across. One's on top, one's on bottom. So instead of adding, you're going to subtract. You're going to take 7 minus 4, which is 3. And y, you're going to take the 2 minus the 6, which is negative 4. Okay? Now, right here we got a negative power, so we need to move that. Everything else stays where it's at, because they already have their positive exponents. So 30 to the first times x to the third, 5 to the first. But that y needs to come into the denominator so I can rewrite the power as a positive. And that would be 30, and that would be 5. Now, you got to do something with the 30 and the 5. You're not going to multiply them because they're on opposite sides. You're going to look at your multiplication chart and divide by the greatest common factor. 30 and 5 are in the 5th row, so you divide them each by 5. So 30 divided by 5 is 6. 5 divided by 5 is 1. Okay, so 6 over 1. So 6 times x to the third, 1 times y to the fourth. You really wouldn't need the 1 there, but I put it just so people can see. Okay, story problems. You got 2 shape problems. Patio's width is 5 less than twice its length. Its area is 180 square feet. What are the dimensions of the garden? Okay, so when you're dealing with a shape, okay, first, you need to write an equation down here about area. Your area is 180, and the area of a rectangle is taking the length times the width. Now, make a parentheses to represent the length and the width, but you need to fill out the parentheses so that they both have the same letter. And that's where this is comes into play. W equals, okay, and then put length on the other side and work your way backwards. Twice, that means 2L. 5 less, minus 5. So in that W parentheses, we put the expression 2L minus 5. And in this, we're just going to put L. Now multiply that out. So 1L times 2L, and then 1L times negative 5. So it's going to be 2L to the second and then negative 5L. You can't combine anything, so just drop that down here. 2L to the second minus 5L. Okay, now you got 2 roots to find for L because it is to the second power. Now you also have the L that isn't to the second power, so you need to get a 0 on that side so you can use your factoring / quadratic formula. Okay, now I'm going to decide if I even need to do the GCFT chart. I'm going to go to my discriminant. So b, -5. Remember, you need two parentheses at the beginning. -4. A is 2. C is -180. Yeah, that's definitely irrational, so a t-chart would be a big waste of time. Okay, so quadratic formula. Okay, so we got 5. A on the bottom is 2. B squared would be -5, 4, and then A is 2. C is -180. Okay. So you got 5 and then 4 on the bottom. It's going to be 25. Remember, it's always positive, that second power. If you get negatives because you're not putting in that, just take it times itself. -1,440. $1,465. And then I find the square root of 1,465. It's probably going to be the same thing that I just punched into my calculator. 38.28. If you go 27, that's fine too. 5 plus 38.28 divided by 4 is 10.82. That's a pretty good answer. Okay, and then 5 minus 38.28 divided by 4, -8.32. Now ditch the negative root, just forget about it. And 10.82 is my length. Then to find my width, I come up here and replace my L with the root I'm using, 10.82. $16.64. Now you can always check your answer by multiplying them. It should be dang close to 180. It's not going to be exact, but yep, it's about as close as you can get. Okay, the next one. The cube's length is 3 units more than its height. The cube's width is 4 units more than its height. The cube's volume is 20 cubic inches. Find the dimensions of the cube. So it's just like the last problem, except this is a volume. Volume is length times width times height. That's a V there. Okay, so let's make a parentheses like we did on the last one. Length, width, height. Okay, so we use these equals so we can get the same variable in all my parentheses. So length equals 3 units more than the height. So H, 3 units more plus 3. So in the L parentheses, I put H plus 3. Now there's another one. The width is 4 units more than its height. So height's the other one. Work your way backwards, you just see 4 more, so H plus 4. So in the W parentheses, we put the expression H plus 4. And in here we just use H. Now I have all H's. Now I'm going to FOIL these. That's H squared, 4H, 3H, and 12. These combine to make 7H. Okay. So now I have 1H to the second plus 7H plus 12. But you still have to multiply by the H that's right here. You can't forget that, but that's easy. That just goes 1H to the third plus 7H to the second plus 12H. You're just multiplying all these by an additional factor of H. Now you're good to go. Now there are 3 roots. There's also other H's not to the third, so we got to get this 20 out of here. And now I have 1H to the third plus 7H squared plus 12H minus 20. But I can't do the quadratic formula because there's more than 3 terms. And I really don't want to set up the grouping method, so how about I use the rational roots theorem? So you got 20 and 1. Factors of 20, 1 and 20, 2 and 10, 3 is a decimal, 4 and 5, that's it, and then 1. Divide all those by 1, it's just 1, 20, 2, 10, 4, and 5. Now start plugging those in. You don't have to do negatives on these, and as soon as you get one of these to work, you don't really care about the other two. I mean, these are the ones that would make sense to have as my height in a volume. Oh, I got 0 right away. Nice. So 1 works as your height. You don't need to. The other, you're like, what about the other two? Who cares? They're just going to be either negatives or i's. Okay, that's not going to make any sense when you're doing a story problem. So now I look at your length. 1 plus 3 is 4. 1 plus 4 is 5. Now if you multiply those, there you go. Okay, and the last one. One of the costs to print novels can be modeled by the equation c equals x to the third minus 10x to the second plus 28x, where x is a number of novels produced in thousands. The company prints 5,000 novels at a cost of $15,000. What other numbers of novels produce the same amount? Now write the equation that you were given. Anytime they give you an equation in a problem, you want to write it down and then go off to the side and define what the variables mean. Now C is your cost, that's money, okay? Because remember we said X can't be money, so C has to be the money. Then X is whatever the item is we're selling, which would be novels. Now what values they give me? Well, 5,000 novels, we're just going to use 5 for that value. And at the same time, it costs 15,000. Now put those in at the same time. So 15, I'm going to put a 1 there, we'll need it later. 1 and then 5 to the third minus 10, 5 squared plus 28 and then 5. Okay. So plug that in, see that it equals 15. It should. Bam, 15. So the equation's right. Now I want to keep this at the cost at 15, but I want to find other x's, other numbers of novels that would cost 15. All right, so you got 3 roots, and guess what? You already know one of them. What's the number you just had in for your x? 5. So I need to get the rest. I get the 15 here to 0. I'll just put it at the end. And you're like, well, rational roots theorem. Not really, okay? I already have one of the roots, so I don't need the rational roots theorem because I know I can put 5 there. So 1, negative 10, 28, and negative 15, and away we go. Because you have to find the other two actually on this problem. Add negative 5 times 5 is negative 25. Add, that's 3, 15. Okay, so that's now 1x to the second minus 5x plus 3 equals 0. Now if you want to use your discriminant to see if you even need to use the t-chart, be my guest. That's what it's there for. Yep, we're going quadratic formula. Opposite of b plus or minus the square root. B squared minus 4ac over 2a. Opposite of b is 5. B is negative 5. 4a is 1 and c is 3. And a here is 1. Okay? So you got 5, 2 times 1 is 2. So negative 5 times itself is 25, and then 4 times 1 times 3 is 12, and that's 13. Then I evaluate the square root of 13 to get 3.61. Then I'm ready to go. 5 plus 3.61 equals, divide by 2, 4.31. 0.70. Okay, all those are legitimate answers because they're all positive and they're all real. There's no i's. Okay, but I would like you to put 1,000, 1,000, 1,000, 1,000. Okay, because x is novels. Those are in thousands of novels. That'd be 5,000, 4,310, and then 700.